Your challenge in this lab is to determine the best metal for a commercial application. And in this case, the commercial application is construction of a fleet of school buses. Now, the driving criterion for this is choosing a metal that resists corrosion. And corrosion is really the reaction of the metal with oxygen to form the metal oxide. And the reason that's bad is because when a metal forms a metal oxide, the metal structural integrity. It's prone to degradation and therefore not a good material for a bus. You don't want something that can just crumble apart to form the material for your school bus. That would be a bad thing. Now, in this challenge, reactivity is going to serve as a proxy for corrosion. So in other words, if a metal is unreactive with other things, we're going to assume that that metal is resistive to corrosion. Now, I want to show you an example of how you can start to deduce whether a metal is good at resisting reaction with something else or not. And again, if a metal resists reaction with something, we would call it inert. And that would be a great quality for a school bus to have. We don't want it to go out in the elements and start to react with the elements and potentially degrade. So back to the example. I have here a solution of copper chloride. It's got the characteristic blue color of the copper 2 ions. I'm going to pour into my beaker. And I have here some aluminum foil. Aluminum is a metal, okay? In this case, it is in foil form. So I'm going to rip off a pretty good size piece of my aluminum foil. I'm doing this very kind of qualitatively, as you can see. And I'm going to put this aluminum foil in my copper solution, and I want you to observe what happens. Okay. So what you're looking for are signs of a reaction. So in this case, if you observe the aluminum over time, what you'll notice is the aluminum reacts with the copper chloride. And I'm going to add a little bit more here to see if we can see evidence of this happening on a faster time scale. Now, at this point, this has been sitting here for a couple minutes, and you can see towards the bottom of the beaker, you see evidence of a chemical reaction. You see some reddish solid. And you can see if you look at the edges of the foil, you can see it start to kind of peel away. So when we put aluminum foil in copper chloride solution, we see a reaction happen. Now, if, theoretically, you expose aluminum to something that had this kind of reaction with it and it degraded, that would be a bad thing if we constructed our bus of aluminum. So in this lab, what you're looking for is a really inert metal, something that stands up to the elements, something that if you take it outside, it really doesn't have a lot of reactivity. It's stable as is, and therefore a great material for construction, particularly of a bus. Now, other things you consider are cost, okay? For example, gold happens to be a very inert metal. It doesn't react with a lot of things. But why wouldn't we use gold to make school buses? Well, it's really expensive. The same thing goes for silver. So when you set this up, that's another consideration. And you can look into the cost of metals by going online, okay? So, you might not come out with the same answer as the next person. You might choose a metal that has some reactivity, but you don't think it'll be a problem, particularly if the metal is widely available and low cost. So this is what is engineering about this. There's always a trade-off, okay? But the main criteria you're going to be evaluating here is corrosion, and as a proxy for that, you're going to use reactivity. Now, if you just got done with your challenge on choosing the best metal for a school bus, let's talk about some things you may have seen, depending on how you set up your experiment and how you decided to test these different metals. What we did is we tested these metals, tested their reactivities in a variety of solutions. So, for example, here's a strip of copper. We tested whether copper reacted with copper chloride, iron sulfate, aluminum nitrate, and some other solutions. Now, the metal that we saw that didn't have any reactions, it didn't react in any of the solutions, was copper. And so we decided to choose that as our metal of choice for school bus construction. The other metals we saw were quite reactive with most of the solutions. Some weren't as reactive as others. For example, aluminum might have been a good choice. We decided to go with copper because when we went online, we saw that it was widely available and also very cheap. So those two things combined with the idea that it wasn't reactive with any of the solutions, we thought this would be a good choice to construct our school bus. The other thing that you should note about metals, if you compare them to plastics, is you can see that this piece of copper is very malleable, and therefore could be easily shaped into a school bus type design or something else. So it's flexible enough to withstand repeated vibration like you would experience on a road, but also strong enough to bear heavy weights. So in the end, our test led us to copper. If you chose a different metal, that's fine. You would just want to justify it.